Hello and welcome back. In this video, we will understand how the Spring Boot application works internally when deployed on a Tomcat server. You know that you can create applications with Spring Boot and then can deploy it in different web servers like Tomcat, Netty, Jetty, Undertow. There are so many servers. But particularly whenever you start a Spring Boot application, by default, it is deployed over a Tomcat server. Now we're going to be understanding what actually happens when the user will hit a request and how the user request is basically processed by the server. And we will understand the core working principle of a Tomcat server, which is the thread per request model. And once we understand this, we will see how our Spring Boot application works with Tomcat with virtual threads activated and how the Spring Boot application is working with other servers like Netty or Undertow. Okay, so right now, let's just get started with very simple. The way the Spring Boot application is working with the default configuration, that's with the Tomcat server. All right, so right now, let's just check how the Tomcat server works under the hood. What actually happens when a request comes into your web server. Imagine this is your Tomcat server. Imagine these are the piece of code that you have written in your Spring Boot application and you have deployed it inside the Tomcat server. Now there is a user request is coming in and that's /data. And let's say there is an endpoint available inside your application called /data. Now the user hears the same request. Now, this is the piece of code that you have inside the Tomcat server will be executed. But how basically that code gets executed? Let's just check over here. Here the story begins. You have a pool of threads inside any web server. Like in the Tomcat server, you also have a thread pool. And this is the server pool. And here inside it, you have different threads. And what is a thread? A thread in Java basically does some task. So here inside this Tomcat server, all this thread also will do some work or also will do some task. And that task is to process the user request. Now imagine there is a user which is hitting this endpoint called /data. Now one of the server thread from the Tomcat server pool will be assigned to this particular request in order to process this request. Right now, all this code that we have will be executed line by line. This thread responsibility is to execute all the piece of code that we have over here and then return the data, giving a response to the user, whoever hit the request. So the thread responsibility is to process the entire request and response cycle. So right now, imagine here we go to the next line. So in this line, let's say there is nothing much is happening. So once the execution is done, we will go to the next step. But let's say here we have written some code which will make an external database call. So we may have some database query which is basically hitting our database. Now until and unless the database will respond back and send the data to our code over here, the thread is blocked. The thread is sitting idle because the thread responsibility is to process the entire code and then sending the response back to the user. So as long as the execution is going on, this thread is going to be blocked. And that's a very serious concern. Why? You're going to be understanding it in a minute. But right now, let's just say this DB is not responding us back. But after a while, the DB responds back, and right now we can simply move to the next line of the code. But imagine here we are making a REST call, or there is another microservices, and to that service we are making a call till the API sends a response back to us. Till then, this thread is again blocked, is waiting. And right now, let's say this sends the response back to our code. And again, we can go to the next line, and that is where we're returning the data. And once we return the data to the user, let's say this is the response that we'll be returning, then the request and response cycle is over. And the thread which is handling that can right now safely go back to the pool. Now this thread is readily available to handle another request. So this is what we call the thread per request model. For each incoming request, we're assigning a thread to process that particular request. So everything is smooth and happy. But this can be really dangerous when we have some concurrent users are hitting our server. Let's say there are thousands of users who is hitting this endpoint called /data. At that time, how your Tomcat server will accept all the 1,000 users request and how it is going to handle the load. What kind of performance it is going to give in high load. Let's just check that out with another use case. Now imagine you have deployed your Spring Boot application. Imagine this code are part of your Spring Boot application and you have deployed your Spring Boot application inside the Tomcat server. And inside this Tomcat server, there is a server pool where 2 number of threads are available. Knowingly, I have taken only 2 threads over here, but in reality, in your Tomcat server, you have 200 number of threads. When your Spring Boot application actually bootstraps, you have 200 default threads available to handle 200 concurrent requests. But in this case, I have limited it to 2 number of threads just to show you how our server performs when concurrent requests are coming or when multiple users are trying to hit our server in the same time. Okay, so let's say there is a request coming to your Tomcat server. Now, one of the server thread is assigned to handle that request. And now this thread is responsible for the complete request and response cycle for this particular user request. Our program execution will be started by this particular thread. Let's say the first line executes fine. And in the second line, we're making an external REST API call. But here, the API is not sending us the response back. Let's say it is taking a while, it's taking a bit of time. In that case, as I said, the thread is simply going to sit idle. It's not doing anything because it's already made a call to this API, but this API is not responding back. In the same time, if there is another request will come, then what will happen? Then obviously, this thread cannot process this request because this is sitting idle serving this request. Right now, we have another server thread or another worker thread is available on the pool. This server thread will be assigned right now to handle this request. Now for this request, this green request, now the execution starts over here. Again, line by line, the code execution will be done by this thread. Now, whoever made this request, for that request, the execution started. But in this point of time, again, we're going to make a REST call because this code does that particular REST call. Now you can see for this request also, we're making a REST call to a third-party API. But imagine, again, this is a little bit slower. So it's actually didn't send the response immediately. It's taking a bit of time. So in that case, this thread is also stopped. This is also blocked by this particular request, as this request is also processing. We are yet to get data right now for this request and for this request as well. So all these 2 requests are right now processing. Whoever made this request, their crosshair is right now rolling. And we also don't have any server thread left in the pool. So we will not be able to process any incoming request if somebody is going to hit the request in this meantime. But unfortunately, let's say there is another user request is right now making a call to the same endpoint called /data. Now there will be a problem because to process this request, we don't have any server thread left inside our server pool. So this guy, whoever made this request will keep on waiting because all our server threads are busy processing the other request. So this request will simply go waiting, right? But imagine after a while, this red request, maybe this one who made this request, maybe imagine this request is processed by this API. Now the API is sending a response back to us. So right now we can carry forward with the further execution for this request. Now this thread is going to proceed further with the rest of the code and then returns the data over here, whoever made that particular request. Now, once that request and response cycle is done, this thread will go back to the pool again. Now, the Tomcat server knows that there is another request over here is waiting, right? So as we have a server thread is available right now, now this server thread is assigned to this particular request one more time. So we are reusing the server threads, which is they are inside the server pool. So that's why we create the pool, right? Pool of threads will basically will be reused to process our task. And here in this case, our task is like, processing the incoming request. And right now this server thread is going to begin, request processing for this request. Now imagine line by line, the code will be executed. Maybe over here, we're making a REST call. And let's say it is stuck again over here. Maybe after a while, imagine if this green, response back, maybe the green bar will be continue processing the request and maybe give the response back over here. And maybe the server will be go back to the pool again. And maybe after a while, if this is going to response back, we can proceed further and can complete and can send a response back to the user. And then once it is done, this thread is again will be available on the pool and will be ready to process the further request. Now, the important thing that I want to show over here that these threads are getting reused. But the problem is for each thread, only one request can be assigned to it at a particular time. That's why it is called the thread per request model. For each request, we need to assign one thread from the server pool to process that request. But the problem is we cannot have so many threads. We cannot have 1,000 or 2,000 threads at a time. So in this example, at a particular time, we can only able to handle 2 concurrent requests or 2 requests parallelly. But what about 1,000 requests coming? Then in that case, this server will not perform. So never ever think we can create 2,000, 5,000, 10,000 threads, because all the threads that you are creating and all these threads that you are seeing over here, these threads are basically equals to the OS threads. All these server threads is equal to your OS thread. And you cannot create so many OS threads because whenever you create one thread, this is very, very costly because each thread takes memory, maybe up to 1 MB of memory. So if you're going to keep creating so many threads, you're going to be running out of space and you're going to be getting a memory exception. So the number of threads that you're going to be create is going to be limited. So with minimum number of threads, you need to handle maximum number of requests. That's why you are keep reusing all these threads in order to process those requests. So let's just try to simulate the same example with our Spring Boot. Here, I'm inside my STS, and let's just create a producer application, which is going to produce the data, right? So in this case, imagine we're going to be creating this API, okay? And this API is going to produce some data so that using another application like this, which is going to be a consumer application, we can make call to this producer application, right? So this API, imagine this is going to be a data producer, and I'm going to be creating this application right over here. So let's just create a Spring startup project. I'm going to name this project as Data Producer App, and I'm going to be sticking to the default. I will be choosing here Spring Web and Spring DevTools as dependency, and I'm going to do next. And I'm going to do finish. So let's just create our producer application. And there goes our producer app. Let's just expand this. Inside this source main Java, let's create a controller. So I'm going to create a controller and I'm going to say producer controller. And I'm going to put this inside a package called controllers. Okay. It's going to be a very simple application. I'm going to start with REST controller. And I'm going to annotate that as REST controller. I'm going to have a simple method here, public string produce data, right? And over here, I'm going to be returning some data. So I'm going to returning a string, by the way, over here. Here is the data. And this produce data method, I'm going to annotate this with get mapping. So I'm going to say get mapping and I'm going to say /data. There you go. So our application is ready. And let's just start this. So I'm going to click on this and start this application. And let's just test whether this endpoint is working or not. And our Tomcat is started on port number 8080. And let's just try to hit this endpoint. Localhost :8080/data. And there you go. Here is data. So we're ready with our application development. A very simple app. Just I wanted to create just to show you what happens whenever we're going to be hitting this endpoint. All right, so right now, let's just stop this application and let's just start this application in debug mode. So I just hit this button right now and it is started on debug mode. And I want to analyze what is actually happening under the hood. So I will switch to the debug perspective and I will click here on debug. Now, as you can see, here are the different threads which is running over here, right? And we're going to be finding out our server threads which are running, because here we can see a lot of threads are running. Maybe few of them are Java threads and few of them are created by your Tomcat server. For an example, as you can see, there is something called thread destroy JVM and which is running right now. And this thread is basically started by your Java virtual machine. And now we are not concerned about this thread and also all the other threads which are running. We are only concerned about these threads. So as you can see, there are threads running HTTP Neo 8080 exec1. And like that, you have exec2 running, exec3 running, exec4, exec5 till exec10. These are the threads what we call the worker threads, or these are the threads what we call the server threads. And we are mostly concerned about these things because these threads are going to be responsible to handle the incoming request. When any user request is going to hit your server, these are the threads which is going to handle the request. Now just remember this thing. The threads starting with HTTP Neo 8080 exec and then -1, -2, -3, those are the threads what we call the worker threads. Right now, why there are 10 number of threads has been created? Well, whenever your Spring Boot starts, as I said, the default thread count is 200 for a Spring Boot application. But whenever your Spring Boot application start, by default, it is going to create a thread pool of 10 threads. And all these threads, as you can see right now, are running and waiting for a request to come. One more thing you have to notice here, these threads are daemon thread. And as you know, daemon threads means background thread. So all these threads are the background threads running behind the scene and waiting for a request to arrive. So once the request will arrive, one of this daemon thread or the background thread will come into the action and gonna be processing that particular request. Okay, let's just see that whether that is happening or not. So let's just do one thing. Over here is the data, the response that I am returning. I also want to return which thread basically handles the request. So I'm going to do thread.current thread.getName. Just to check, this request has been handled by which thread. Okay, let's just do Control S. Let's just go to the web browser and let's just do enter. And you can see this request that we hit right now has been handled by this thread, the exec1. And if you're going to refresh this, you can see the threads which are handling the request that I'm hitting. And all your server threads, you can see over here, and for a particular request, a particular thread is handling the request, right? So you can see that in action right now. Okay, so for now, we have just started our Spring Boot application in debug mode. And we can see all these threads are running right now. But I actually want to see how these threads are handling our request. So let's just do one thing. Let's just put a breakpoint here on the line number 12, okay? And my application is already running on debug mode, as you can see. I think if I'm going to switch the perspective, it's already running on port number 8080 and on debug mode. Let's just go over here to the web browser. Okay, right over here. Let's just hit this endpoint one more time. Okay, you can see my application stuck over here. Okay, I haven't got the response. It is still rolling. And right now, if I'm going to go back over here, you can see one of the background thread or the daemon thread, in my case is HTTP Neo 8080 exec4, is basically handling the request right now. And in Eclipse, whenever you run your application, whenever you're going to be seeing suspended breakpoint at line number 12 producer controller. For producer controller, line number 12 in the breakpoint, the program has been stuck. So whenever you see suspended, this confirms that the exec4 thread is basically handling the request. And right now, let's say if I'm not going to resume, if I'm going to do resume, the response will be served over here. Let's say if I'm going to do resume, You can see right now the exec flow is right now free and right now running. That means it is running and waiting for the next request to come. But none of the threads are right now performing any tasks. They all are running. They're just waiting for the next request to come. And over here, you can see it is no longer running. And you can see this request has been handled by the exec flow and is completed. Right now, let's just hit this endpoint one more time. Maybe I'm going to go to the new tab and I'm going to hit this endpoint one more time. Okay. Now, in this case, who handled the request? See, exec5 handled the request and is suspended. Let's say in the same time, I'm going to go and create one more. Okay. And I'm sending one more request. And in this case, let the flow come to my STS because I hit another request. I think another thread right now is going to handle that request. It is yet to happen. Let's just wait till the flow to come. And you can see right now, the daemon thread exec6, okay, HTTP Neo 8080 exec6 is right now handling the request, which is coming from this browser tab. Imagine this is another user is hitting that request. Imagine I'm going to hit another request right over here. Okay, do enter. Okay, again, a new thread will be assigned to handle that particular request. And we're going to be looking into that right now. Maybe I'm just doing all these things from my local, so it's taking a while for the debug point to kick in. Okay, so but we can wait. You can see only 5 and 6 are busy processing the request. Other are running and waiting. And now you can see the 7, the exec 7 is handling the new request right now. Okay, but let's say the exec 5 is done with his work. Now I'm going to resume this. I'm knowingly putting a breakpoint over here just to make sure I can stop the thread and I can show you the scenario and the use case that we're trying to prove. But imagine the exec 5, maybe the first user request handled by the exec 5. Maybe this one I'm going to be resuming. So I'm going to hit on resume right now. And you can see it has been resumed right now in the running status. That means, again, it is free up and waiting for the next request to come. If I'm going to go back, you can see here I got the data. But here, this one, let's say this is handled by the exec 6, and I'm going to resume this. It's stuck right now, right over here. I'm going to free this up, and you can see it's changed to running. And over here, we got the result, okay? Handled by exec 6, and here is the data. And over here, this one, if I'm going to come over here, resume this one more time, this is freed up. And right now, I can see all of my 3 requests has been served. But the important point to notice over here, every request has been assigned to one individual threads, and one thread is responsible for processing the entire request. In case there is something long running task is going on over here, that thread which is handling that request is blocked. That thread which is handling that request is sitting idle, not doing anything, not handling any other new request. This is just taking that as a responsibility to process the request that it is handling. And once that request and response cycle is over, then it is going back to the waiting stage again and waiting for another request to come in. Maybe the exec 7 will handle a new request as it is available right now. Okay, hopefully this much is clear. Now let's just go to our consumer application. For now, we have set up this application. We understand few things. Imagine this is our API. Imagine this is the API that we have created. This API means this. And right now, let's just build this application. We will create a Spring Boot application. We will have a Tomcat server. We will make sure we will have less number of threads, maybe 2 threads in our Tomcat server that we will be creating right now. This application, let's just create and let's just write this code with 2 number of threads, and then we will try to make call to the API to this application, all right? And we will just see what kind of challenges that we face if we have only couple of threads available. So we are done with this application, which is our producer application. Let's just go with our consumer application and let's just create this one, okay? All right, so our producer application is up and running. Let's just try to create our consumer application, but I don't want to create the consumer application in Spring Tool Suite. Rather, let's just use IntelliJ. So right now we are running it in STS. So let's just do one thing. Let's just bring off our IntelliJ, and our consumer application we will create right with the IntelliJ. So I'm going to create a new project, okay? and I'm going to create a new Spring Boot project, and I'll name this project as Consumer App, and rest of the things I'll go with default. The Java version I'll be choosing here as 21, or anything beyond 17 should work. And I think I'll create a Maven project, and I think I'm good to go. I'm going to change my location over here a little bit to store my project, and I'm going to click on next. And here I'll be choosing the Spring Boot DevTools from the developer tool, and from the web, I'm going to be choosing Spring Web, and I'm going to create my Spring project. And there goes my application. So I'm going to bring this into here, and this is my consumer app. And right over here in my source and in my main, in my Java, I can start creating my consumer controller. So right now from my consumer application, as I said, if you're going to see that, flow that I have shown you in the beginning. So right over here, I'll be just creating a simple method with an endpoint. And here, maybe I'll try to call one of the API, okay? Let's say if the API is going to take a bit of time, then how this application will behave with less number of threads available, that is something that we're going to be practicing. For now, let's just try to focus on this method that we'll be developing. Here we have written data, but we can create some other endpoint, because I can see in my producer application, I have already created /data endpoint. So in my consumer application, I can go with like /consume or something, okay? So let's just do one thing. I will go to my IntelliJ, and right over there, let's just create a new controller, and I'm going to go ahead and create a controller over here, and I'm going to say consumer controller, okay? And I'm going to create a REST controller here, and over here, I'm going to create an endpoint, let's say get mapping, and it will be /consume. Let's say consume data, okay? And here, I'm going to create a method called consume data. So I'm going to consume the data from my producer application, which is up and running, maybe where it is running right now, right over here. And this is the endpoint that I'm going to be calling, okay, /data. So let's just come over here to my consumer application. So this is the endpoint that I'll be calling right now, okay, using this consume data, which is running on my IntelliJ right now. Only one thing that I will change over here. You can see whenever I'm hitting, I have a breakpoint over here. So that's why the flow is coming over here. But the response that I'm getting here, I'm getting the thread name as well, which is actually handle that request. So I'm going to remove the thread information right now that was just for testing from my producer application. Okay. So I think I'm good to go. So if I'm going to hit this endpoint right now, and if I'm going to resume, because I have a breakpoint over here, if I'm going to resume it, I think here is the data. So this is what I want. So I'm going to be hitting this endpoint, and I'm going to be getting this data. So let's just try to develop that with IntelliJ right now. Let's just try to make a call to this endpoint. So to make a call to this endpoint, I will be needing a RestTemplate. So let's just create a RestTemplate over here, which is going to be a RestClient, which is going to help me to make a REST call. So I'm going to create a RestTemplate object over here, and using the RestTemplate right over here, I'm going to do get for object, and I'm going to make a get call to this endpoint. So I'm going to be copying this endpoint, and I'm going to be putting it over here. And this is the endpoint that I want to call, right? And whenever I'll be calling this endpoint, what kind of response that I'll get? Whenever I'll be hitting this, I'm going to be getting this as a response. And this is a string. So I'm going to be handling this over here. So I'm going to say string.class, and this is going to get me a string object back. So I'm going to say string response. Okay. And I can send the response back. So I'm going to say return response, and I'm going to end it over here. So this is my consume data endpoint. Let's just see whether it is working or not. First of all, I will just start this application in a different port. So I'm going to say server.port. By default, it is 8080. So I'm going to change it to 8081. And I think I'm good to go. So I'm going to start this application right now. But let's just start it directly in the debug mode. Okay. So my application is up and running right now with the port number 8081. So instead of calling this endpoint right now, let's just hit our consumer endpoint, which is running in port number 8081. and let's say the endpoint is consume data. This is the endpoint that we have created. I think so. So let's just hit this endpoint. Okay, and you can see right now again my producer application breakpoint is triggering, and obviously that will happen because I hit this endpoint called consume data. Now consume data here, I haven't posted any breakpoint here. That's why the flow has not stuck in my IntelliJ idea, but that's fine. I made this call. So this is the endpoint which triggered. This is the line that I did hit. But when I did hit this line, the flow went to the STS, because in my STS, in this server, in this Tomcat server, is actually my producer application is running. The data producer app is running. And you can see the flow stuck here, the application stuck here. And once I hit resume, then only the flow will be released. Well, whenever the consumer application over here, which is the IntelliJ, from the IntelliJ idea, whenever the request is made, from the producer application, one of the thread handle the request. You can see over here, exec3 handles the request, and that is where it is suspended. Now, if I'm going to resume this, it will release this. It will return the data right now, and the consumer application right now got the response, returns the response. So whenever I hit this, I should have got the data. I can see consume data endpoint with the 8081. Right now I got the data over here. Okay. So now just to prove it one more time, what I'm going to do here in my consumer application also, I'm going to be putting a breakpoint. Now let's just go to our consumer app. Let's just close this. Let's just close this. Let's just open a new tab, enter this endpoint, the consumer endpoint, do a enter, see where the flow is coming. It is coming straight to the IntelliJ idea. One of the thread is handling that request. So right now in my consumer application also, whenever I am starting my server, there are the exact threads that are getting created, or the worker threads that are getting created. So if you're going to see on my threads over here, okay, this is the thread which is handling the request. So right now you can see I have so many threads. Let's say exec1, exec10, exec3, 4, 5, 6, 7, 8, 9. All these threads are my worker thread, and they are waiting. Okay, they are waiting means in IntelliJ, whenever you see wait, that means they are waiting to accept request, right? So now these threads are waiting to accept new request. But whenever I hit this request, okay, now this request is handled by the thread which is exec2. You can see I said no whenever the Tomcat starts. By default, 10 number of threads created inside the pool. And you can see right now 1 to 10 is here, but the 2, just look at the status, it is running. And these are waiting, but this is running. This is the thread which is handling this request. Right now, it is said that same thread which is handling the request will be responsible to execute all the lines of code that I have inside this consume data. Now, this thread is going to execute this line and making an external REST call to this endpoint. Okay. And now if I'm going to do resume over here, now this call will be made. If I'm going to do resume over here, see the call will be made, and the flow came to STS right now. One of the server thread from here, that is the exec5, that is actually handling the request. And right now, let's say some processing is going on over here. We intentionally stock our application over here by putting a breakpoint. But imagine if this producer application is taking a bit of time to process this request. But what happens in the consumer side? If you're going to go to the consumer side, you can see the exec2 thread is still running, is still waiting. This is not this wait, okay? This waiting means it is waiting to process the new request. This exec2 is running. Running means it is in the running condition. It is still executing the request that it is handling from here. See, it is still running, right? And if you're going to see over here the thread dump, okay, you can see the exec2 here. The exec2 is runnable, is in runnable state. The thread is in runnable state means it is running, right? The thread have different states. So you might have heard it in your core Java, right? Like running states, waiting states, right? But in simple word, runnable means it is running, is executing. And here is the proof of that. Now this exec2 thread is blocked. We haven't got the response yet. That's why the thread is waiting to get the response. And it is not doing anything else. It is simply running and staying idle, waiting for the response to come. And let's say whenever the response comes, right? If I'm going to do resume over here, if I'm going to put resume over here, okay, you will see over here it will get the response and will return the response, okay? And after that it will be free. And you can see right now here it returned the response. You can see it is no longer running over here. It is no longer buffering, and the thread is right now free. It is not free because you need to refresh it. So if you're gonna get the thread dump one more time, you can see the exec2 is right now not runnable. It is waiting like the other threads. It's waiting for a new request to arrive. Okay, so I told you guys one thing. Whenever your Tomcat server starts like this, if you're going to go to the threads and variable in the thread section, there are 10 number of threads are getting created by default. So let's just try to limit this, okay? So just focus over here. Don't see all this thread because this desktop JVM thread is created by Java, your Java virtual machine. Let's say if you can see the notification thread is also created by your Java virtual machine. We don't need to care about these threads. We just need to care about this HTTP Neo 8081 exact 9 threads. These are only our worker threads, which is going to handle the incoming request. And as I said, if you're gonna go to the application.properties, by default, these threads are set to default 10. So if you're gonna go to server.tomcat.threads means pair, if you can see, there are minimum number of 10 threads will be created at once. And after that, if all the 10 threads are occupied, then if the user request will again come, then it will grow again in the pool. But right now, you can also see the thread.max is set to 200. That means inside the Tomcat server pool, there will be maximum number of 200 threads can be available. Okay, so that's the max has been set for our Tomcat maximum thread configuration. For now, we will remove from 200 to let's say 2. Now with this configuration, let's just restart our server. Okay, and right now let's just go to the threads and variables and threads section. And as you can see right now, right from 10 worker threads, we are right now having only 2 threads, exec1 and exec2. And these are the only 2 threads right now, which is going to be handling our incoming requests. So let's say if I'm going to hit this endpoint, you can see the exec1 is handling this request. And if I'm going to do a resume, the flow will come to the producer application. And if you're going to come over here, check the thread, you can see the exec1 is actually running. Okay, and the exec2 is waiting. Now, if I'm going to resume this thread and going to return this, if I'm going to run this, you can see the exec1 right now coming back to the wait state. And if you're going to check our server, and you can see we got the data right now. Now, let's just say if the 2 requests are coming at the same time. Let's say this is the first request handled by the exec2 right now. Okay, there is another request, Control V. Okay, you can see both of our exec1 and exec2 are running. As these 2 requests are getting handled by the exec1 and the exec2 threads, if a new user is going to hit the same endpoint one more time, okay, now you can see this is also keep on rolling, but the request is actually not accepted by the server, okay, because we do not have any server thread left to handle this incoming request. Sorry guys, we had a power failure here and my computer suddenly, got shut down. My UPS didn't work. So basically, let's just simulate the same example one more time that I was showing you. 3 concurrent requests. Point here is that we have only couple of worker threads available. My producer application is also up and running. So where is my browser? Here we go. This is the first endpoint. Let's just hit this. Okay, so this guy, exec1 right now handles the request. I'm going to resume it. So the producer application will handle the request to process it further. I'm going to hit one more request. Let's just come over here. Let's just hit one more. Yep. So right now the exec2 is handling the request. So I'm gonna resume the program. So the call will be made to here. Okay. So there you go. These are the couple of producer threads which are handling our request. Now the thing is that both of our exec1 and exec2 are running. So if you're gonna check the thread dump, get the thread dump. Okay, you can see both the exec1 and exec2, they are running right now. So what I need to do, I will go back to my threads, check this guy's status. Now I'm gonna go ahead and will make another request. There is no thread right now available on my server to process this request. So what I'm gonna do, first of all, here in my backend, you can see there are a couple of threads handling couple of requests made by the consumer. But the moment I'm gonna resume things from here, let's say one request I'm gonna resume, that means one of the thread will be returned the response to one of my browser tab, and then the thread will be immediately available to process the third request that I'm making from here. Okay, so let's just see whether that happens. So let's just go over here. Let's say the exact one, this request I'm gonna resume. Okay, now you can see immediately the other request which was waiting right now, that has been assigned to the thread exact one which was handling the previous request. That means on my browser tab, if I'm gonna see here, the first one already got the data right over here. Okay, now let's just go to our IntelliJ. The exact one is handling right now the third request. If I'm gonna resume this again, another request will come over here. Let's just resume the second, okay, and let's just resume the third. Okay, so right now all the request has been processed. Okay, you can see right now all the couple of threads are on waiting stage, and you can see I got the data in all of my 3 tabs. I hope you understand how this thread per request is creating a problem whenever more and more concurrent requests are coming, right? I'm going to be showing you another problem here. Let's just go to our consumer application, and right over here, let's just create another simple API. I'm going to have a get mapping, and I'm going to say simple consume, and I'm going to have a method called simple consume. And here I will just return a string. Just I want to prove that here I'm not making any external API call like this. Okay, so let's just import this. See how an unexpected behavior will occur over here. So I'm going to restart this application. Okay, and I will go to my threads and variable. I'm going to check the threads which are running right now. There are a couple of threads. Here, let's just log the thread which is going to handle the request, handled by thread. And by the way, this is from my consumer application. Let's just log the thread name over here. Okay, so there you go. There are a couple of endpoints are available in my consumer API. Just make sure that here there is no external REST API call is going on. So right now, let's say somebody gonna hit this endpoint. Let's say simple consume. Okay, let's say simple consume. Here is the simple data handled by the exec2 thread. All good. Let's say right now, let's just hit the consume data endpoint, which is this one. Here we are making a REST API call. So I'm gonna resume it. So it will go to the producer application. Let's say the thread which is handling that request is blocked right now, which is the exact one that's currently running right now over here. So now we have another thread available, which is the exec2 one. So let's just go to our web browser. And let's say if I'm hitting the simple consume right now, see I'm getting the immediate response right over here. And who is handling it? Exec2. That means this request is handled by the exec one, right? So the exec one is currently running. The exec2 is waiting. So this request where we are not making any external REST API call is handled by the exec2 all the time. Now let's say there is another request going on over here for the consume data. Okay. So now the debugger will be triggered in IntelliJ because I have a breakpoint where I'm making the REST call. There we go. And now the exec2 is handling this request. Let's just try to make this call. Resume this. Okay, now it's coming to my producer application. And now the problem is, if I'm going to make a call to this guy right now, even though it is not making any external REST API call or any DB call is happening over here. It's a simple return, but still this will not work because as two of these threads are running right now and none of the other threads are available right now to process the request. See, if I'm gonna hit this simple consume right now, it is also rolling right now. See, this is also rolling. So because of the external REST API call that you are making over here, because this endpoint is behaving slower, because this application is behaving slower, but in your consumer application, you have wasted all your server threads making call to a slower web service. Right now, as a result, the other endpoints that you have over here in your application is not working. Okay, so let's just free this up. Okay, now one of the threads should have been freed. And see, we got the response handled by the exact one because this tab, this request was handled by the exact one only. Once this response is served, I think we got the data over here by the same thread, and same thread is available and processed the request. So before we wrap up this session, one last point that I want to cover here, because this might be important, you might be thinking about it, that okay, I'm using REST template to make the call. And by default, the REST template is blocking. That means the thread which is used to make this call will be blocked until and unless we get the response over here. Okay, that thread will not be freed up. Okay, the same concept that I have told you. You might have a question, okay, Avila's REST template is right now deprecated. Yeah, we are not getting any deprecation mark over here, but this is deprecated, I think, since Spring Boot 2 point something. This is not a hard deprecation. This is a soft deprecation. If you can see, they are asking us to use RestClient. So Spring is even recommending us not to use it. Maybe right from the 6.1 or as part of the Spring Boot 3, which uses Spring Framework 6.1 behind the scene, we have a new component called a RestClient, which will be the substitute for the REST template. So instead of using REST template in our latest version of Spring Boot, we are getting something called RestClient. Using that also, we can make REST calls. So if I'm going to comment this REST template, and if I'm going to comment out this call that we are making over here, instead of this, we can use something called a RestClient, which is a more modern API to make a REST call. So I'm going to say RestClient is equal to RestClient.create to create the RestClient object. And then the RestClient gives us a more kind of a Fluent API. Fluent API means this is kind of a chain kind of method that we're going to get. So I'm going to do RestClient.get, then .URI, and I can pass in my URI. In my case, this is my URI. So I'm going to copy this, paste this over here. And then I'm going to retrieve the data and I'm going to get the body out of this request. Whenever it is going to respond back, I'm going to bind it with a string type and I'm going to handle that thing over here. I'm going to say string. So this is a more modern way of making a REST call. And by the way, the only difference here is the REST template over here is not Fluent. This is more Fluent. Fluent in the sense there are more of chaining APIs are available just to, we can just chain the things and it will be more readable if you're going to compare to this kind of thing. For an example, if you want to add headers over here inside this REST call, you can just do header and you can pass in the header over here. But in the REST template, if you want to pass in the header, then you have to use some other methods. You're going to be using some methods like exchange. So over here, with the help of REST template, you're going to be using REST template.exchange and maybe using this request entity with the constructor only. You will be passing in the headers and the other stuff. So basically, we can stop using REST template right now if you are coding it right away. Until and unless we're not maintaining any legacy application, we can stick into this REST client approach. This is more easy to read because this is more fluent. But one thing that you need to make sure, this REST client is also a blocking API. The REST client is also synchronous and this is also blocking in nature. Do not think if you're going to use REST client, the thread will not be blocked whenever you are making this REST call. Let's just prove that. Let's just restart our application and let's just simulate the same example. Why I'm using the REST client, I'll tell you, because some people will be confused while debugging. So let's just go to the threads and variables in the threads section just to make sure we have our couple of threads are up and running and waiting for new request to come in. I will activate the debug point over here. Let's just have another sys out, start our application in debug mode. And let's just come over here. Let's just hit consume data. And you can see my application stuck over here. Now it is handled by exact2. Let's just resume our application right now. It's coming to our producer application. And you can see right now, if you're going to go to our threads, you can see both exact1 and exact2 are waiting. Okay. So seems like the thread which ran this particular code that actually fired the call, and the call went to the producer application. You can see one of the thread is handling the thing over here, your application stuck over here. But the thread which actually fired this request, okay, that thread is showing you in wait. That means it makes the call and then is freed of itself. It is not running. Both of the threads are showing in waiting state. Do not think this is a non-blocking call. Do not think the thread which actually used to made this request is not blocked. Never assume like this. Why I'm saying you that? Let me show you. Let me just do resume. You will see I'm gonna get the data over here in my browser. Okay. Let me hit this again. Enter. Okay. Now see which thread is handling it. Exact1. Okay. Remember that exact1 is right now running and it is handling this request, right? So let's just do a resume. If I'm going to do resume, this will be executed. So I hit resume. See the flow came over here. Now the exact1 is showing you in wait, but it's not actually waiting. It's running. If you're going to see the thread dump, okay, see the exact1 thread dump. It looks like the thread state is waiting, not runnable, but have a look over here. Okay, here only you made the call, consumer controller Java 21. Here only we made the call, right? If you're gonna expand this, okay, you can see behind the scene, it is making a call using completable future.get. Okay, so it is using completable future doesn't mean that it is making a non-blocking call. Okay, it is using completable future.get. .get is a blocking call. That means once you made the request over here, you are still waiting for the request. The thread is still running and blocked by this .get method. You can see it is blocking the things, right? So if you're going to see over here, if you can go back, one of the thread is processing this request. If you're going to keep on hitting this simple consume, you can see always the exact2 only. If I'm going to keep on hitting this, the exact2 is only handling the request. Okay, every time if you're going to hit it, the exact2 is only handling the request because the exact1 is still waiting and blocked by this REST call that you are making over here. And as it is using completable future, it looks like it is not ideal and it's waiting to accept new requests, but not actually. It is actually blocked behind the scene. Okay, so do not predict. REST client is a non-blocking operation. If you're going to put your breakpoint here one more time, if you're going to resume the request from your producer application right now, come over here, resume this, you will be seeing the same exact1 thread is going to handle the request. Okay, see, right now, if you're going to go to your thread variable, see, the exact1 is started running again. And if you're going to see the thread dump, okay, the exact1 is right now runnable. It's the same thread which is right now got the response and we got this response back. Now, if I'm going to resume this, we're going to be getting back the response over here in the browser, right? So you can see it's not buffering anymore. I don't know which tab I did hit it. Okay. So do not predict the REST client is helping you to make a non-blocking call. No, both REST client and the REST template both are blocking. If you are using either one of them, your request will be synchronous. The thread will be responsible to process the request step by step. It is going to make this call and going to wait for it to get the response back. Once it gets the response back, it is going to help you to return the response. Once the response is returned to the user completely, then only the thread will be freed off. Now, if you're going to get the thread dump again, you can see the thread is right now free and is ready to handle the new request. So in this entire video, I was just trying to prove that the threads that you are using behind the scene to process your user request are actually getting blocked throughout the request and response cycle. And inside your Tomcat server, there are some certain number of threads that are available. Let's say if you have 200 threads, you're going to be using that 200 threads only to serve the incoming user request. You cannot create 1,000 or 2,000 or 10,000 threads to handle 10,000 concurrent user requests, because all the threads that you are creating inside your server is going to be equal to a OS thread. And you cannot create so many OS threads. Your OS only will not allow you to do that. So if we are sticking into the thread per request policy, then we might need 1,000 or 2,000 or 10,000 requests to handle 10,000 concurrent requests, which is not possible to achieve using a normal Spring Boot application until and unless we are scaling it up. But with virtual thread, we actually can do that. With Netty server, we actually can do that. Well, all these thread handling things happening behind the scene. And if you have just started your Spring journey, you might not have bothered about all these things because it's all happening behind the scene. But this is a serious concern that you, in case you have just started Spring, you also need to understand this. Because in today's era, there will be a lot of traffic will be incoming to your server, and you should know how to handle all those requests. So in modern Java, in Java 21, we have an awesome new feature called virtual thread. And Spring people right now have given support to the virtual thread, because using virtual thread, you can create millions of threads to handle millions of requests. But I also told you thread creation is costly. You cannot create so many threads. But how I am saying using virtual thread, you can create millions of threads. That's the thing we're going to be talking about in our next video. So in the next session, we're going to be trying to integrate virtual thread with this particular application. And also we're going to be seeing what kind of challenges virtual thread solves and what kind of challenges virtual threads doesn't solve. And why do we need the reactive programming or a server like Netty? And when we should choose Netty server over Tomcat server. Everything we're going to be talking about in the next session. I hope you're interested. If you found this video helpful, make sure to give me a like and subscribe to this channel. I'll see you guys in the next video, which will be very, very interesting. It's too hot here. I don't know, there is some work going on outside, some electrical work, and there is a power cut. And it was really, really hot. I'm sweating like anything for the last couple of hours. So let's just go from here and let me chill a bit outside. Okay, I'll see you guys in the next video. Till then, bye-bye. Take care and happy coding.